Okay, here we go. It does. I want to go ahead and I want to review just a little bit over logarithms. Okay? Or in this case, exponentials. We haven't talked about graphing exponentials for a little while. It's been about a week and a half. But you're going to find a lot of parallels from what we've been doing to what we're doing right now. You're going to find out that even though we haven't really done it in a while, you really have been doing the same kind of operations. So let's just kind of look through some of these. The parent function is y equals 2 to the x, right?
Yes.
When we were choosing the parent coordinates, what were the x's for exponentials? Good. Negative 1, 0, and 1. Anybody want to venture to guess what the y coordinates are?
Negative 1, 0, 1.
The y coordinates.
Oh, 2, 1 half.
1 and 2.
How is that kind of related to what we've been talking about? They're just switched, but isn't an inverse of an exponential a log? So you would just swap the x's and y's? Shh, listen. It's exactly the same here. And so I'm going to go ahead and graph my new coordinates. How do we get these numbers?
Add 4 for y.
Add 4 to the y coordinates, right?
And you add 1.
Add 1 to all the x's. Let's go ahead and finish it out. The question was, how do we know what the asymptote is from an exponential graph? Okay, it's your vertical shift. How much up or down you went is your horizontal. It's your horizontal asymptote. So y equals 4. Let's go ahead and plot a couple of the points and graph my line. Go ahead and use your graph paper to do these. The domain for an exponential is all real numbers all the time. What's the domain of this question? The domain is all reals, but not the range. What's the range? Y is greater than 4. Your graph exists above the asymptote. So, well, what's my asymptote? Well, we've got it written right there. It's y equals 4. So your graph is above that, so you say y is greater than 4. Okay? What about the increasing interval?
0, 4.
It's increasing because it's going up. Does it go up the whole time? So what's my domain? If it's the whole time?
Infinity, 4.
Negative infinity to positive infinity. Remember, we always use x values for this kind of graph. We don't ever use x values or y values to do the increasing and decreasing part. Okay? What about in behavior? Take a second. I want you to write out the in behavior. It's definitely increasing from negative infinity to positive infinity. Look at the in behavior. What's x goes to? Which one? X goes to negative infinity and positive infinity. What about the y value for negative side?
It goes positive.
As x goes to negative infinity, what happens to y?
It goes positive.
Careful.
Goes negative.
As x goes to negative infinity, as x goes to the left, what happens to y? Good, it goes to 4.
That's the asymptote.
Exactly. And as we go to the right side, it goes to 4 and positive infinity. Okay? What about the X-Intercept? How do we know that? None. Because, well, the asymptote prevents it from getting down to the x-axis. Right? And so, if we look at the y-intercept, we did that in our table. Tip. If your table contains x of 0 or y of 0, then you've got one of those asymptotes. Or, no, sorry. You've got one of those intercepts. Don't do all the work extra. Okay? Questions on this one. This is what I expect you to do. So in terms of the problem, you're supposed to work this one out. Okay. So number 7, you have log base 3 of x plus 4, or sorry, negative x minus 4 plus 3. Okay? I'm going to do number 7 for you. 6 and 8 you're going to have to work with on your own, see what you can do with it. But I want to take care of the negative sign inside because we really haven't had one of those. So let's write out my parent function. Just kind of get started. So x and y, we know we're going to have negative 1, 0, and 1. What's my x values for this parent function? Good. So let's look at the new function. We're going to have x and y. Now, I'm going to kind of give you an idea of way to think about working with that x, the negative inside. Let's take care of the y since it's really just straightforward. Let's go ahead and get that out of the way. What are my new y coordinates going to be? Good. I'm just going to add 3 to each one. So 2. Perfect. All right, here we go. Be careful. What we're looking at here is really going to make a difference. Because we have that negative sign on the inside, what is that going to do to my coordinate? Which one? Just the x's. So what does minus 4 do? I'm going to add 4, and then what? I'm going to change the sign. So let's go ahead, add 4 to all the rest of them. So it's going to be 4 and 1/3, or 4.3, but it's going to be negative, right? So 4.3, we'll change that sign. We're going to add 4, that's going to be negative 5, and then 3 plus 4 is going to be 7, and we'll make that negative.
1/3 as the x.
Because it's the base, 3. Okay, now, here's the tricky part. Here's where a lot of you... What's my asymptote going to be?
Negative 4.
It's negative 4. Because not only does the points get reflected, the asymptote gets reflected too. Remember, the asymptote is part of the x stuff. Okay? So we're going to go over, we're going to take the asymptote, it's going to be negative 4. So it'll be right here. And so this is x equals negative 4. If you were to plot that, negative 4.32, so here's 1, 2, 3. Negative 5, so 4.32 is be about here. And then negative 5, 3 will be here. And then 6 and 7, and then 4. So it'd be like this. So it'd look kind of like that. That's kind of messy, but you get the idea. So the way that you handle this problem is you go ahead and do the translation and then change the sign. Don't forget about changing the sign of your asymptote. It wouldn't be a big deal because when you go to plot your points and you realize your asymptote is way on the wrong side, I think that'll be good to remind you of which way it goes. So be careful about the negatives. Word of caution, number 8. It's negative on both sides. So you've got negative reflections over the x and reflections over the y. So that means they're going to be changing the coordinate signs for both x and y. Okay? That's a tricky one. I want you to work on that one. We'll talk about that one tomorrow in class.